SETI. SETI es un instituto que busca la vida extraterrestre, busca su origen y la prevalecencia de la vida en general, incluso en la Tierra, pero con miras a la vida extraterrestre, ¿no? Es un tema que está bastante de moda en estos momentos, porque ahora se están encontrando con nuevas técnicas de observación muchísimos planetas y en el futuro se van a encontrar muchísimos más. De hecho, al final de la semana vamos a tener una charla sobre esto y el sábado otra sobre vida extraterrestre, así que si quieren pueden volver a saber más sobre este tema. Seth estudió en la Universidad de Princeton, hizo su doctorado en Caltech. Después de 13 años trabajando en Holanda, se incorporó a donde está trabajando ahora, en SETI. Bueno, tiene un sinfín de premios. Aquí dice que más de 400 artículos científicos publicados. Eso es, para el que no sepa del tema, eso es muchísimo. Es autor de 4 libros, ha trabajado muchísimo en divulgación, en extender lo que es la ciencia, tal y como trabajan los astrónomos, al público en general para que la entendamos. Y ha ganado en 2004, por ejemplo, por poner un ejemplo, el premio Klumpe Roberts, otorgado por la Sociedad Astronómica del Pacífico, que es una sociedad muy importante en ciencia. Bueno, sin más, me gustaría que le diéramos un aplauso al doctor Seth Shostak. Les dejo con él.
Yeah.
Sí.
This is it.
Bueno, les quiero decir que van a tener la oportunidad de practicar su inglés, porque la charla va a ser en inglés, no tenemos traductor. Espero que la disfruten.
Okay, is this working? Can you all hear me? How many of you do not speak English? So how can you understand that question? Okay. This will be in English. Unfortunately, I speak very quickly, typically 400 words a minute, but for this audience, I'll drop it to 395. I want to thank Helene for a very nice introduction. About 10% of that was true. I'd also like to thank you all for coming to what will undoubtedly be a very strenuous talk to listen to. I know how difficult it is to listen in somebody else's language. I'm going to tell you a little bit about why we think ET, why we think the aliens may be out there, how we're looking, and how it would affect you, the residents of Mexico, if it were to be discovered. How many of you think that there are aliens out there, intelligent aliens? All right, well, how many of you think no, probably not? One guy. Okay, well, if the rest of you are already convinced, there's no point in this talk. We might as well go out and have a cup of coffee. All right, the real reason that astronomers believe that they're probably out there comes down to this. It's a numbers game. We have not found any life beyond Earth, not yet, alive or dead, not even bacteria. We've not found anything, nothing. But I think that's going to change in your lifetime. I think in the next 20 years, we're going to find some sort of life. It may be stupid life on Mars, microbes or something. It might be intelligent life on a planet far away. It might be only indications of life by finding oxygen, for example, in the atmosphere of another planet. But this is why we think they're out there. This is a photo from Hubble. This is a deep Hubble field. Many of you have seen this photo. Every one of those little blobs there is a galaxy. So each one of those is 100,000 million stars, roughly. And there's one star there, but the rest are all galaxies, okay? In fact, if we could turn the lights down a little bit, maybe you could see this better. You don't need to see me. Seeing me is just an aesthetic offense. Okay, anyhow, if you made photos like this all around the sky, something for which the NASA budget is not adequate, but if you were to do that, you would count 100,000 million galaxies, each with 100,000 million stars. So that's the number of stars in the part of the universe we can see. There's undoubtedly much more universe that we cannot see. In fact, it may be infinitely more, but in any case, it's a lot more. Okay? So for the fellow in the back here who thinks that this is the only place in all of this where there are some intelligent beings, then you have to say he believes in miracles, right? The miracle is not if we find E.T. The miracle is if there aren't any E.T.s to find, because that makes you the smartest things in the universe. I know you like to think that, but it may not be true. Okay, now that's the number of stars, but what about the number of planets? Well, the number of planets, we're beginning to learn what the number of planets is, because we've been finding planets for the last 15 years around other stars. And if you talk to people who search for such planets, people like Jeffrey Marcy up at the University of California at Berkeley, I asked Jeff, I said, Jeff, if you had a perfect telescope, what fraction of stars would show planets? And his answer was a half, or maybe 3/4. Now, to an astronomer, a half is the same as all, right? There's no difference. For an astronomer, pi is equal to 1, okay? So that means the number of planets in the Milky Way is that number there, trillion. That's the number of planets. How many of them are like the Earth? How many of them could support life? We don't know, but the Kepler telescope is answering that question today. And the answer seems to be that there are a lot of them. This is just a little graphic that somebody made showing how Kepler is finding planets by looking for the diminution, let me say that again, the reduction in light as the planet passes in front of its home star. So these are actual data points here. Gives you some idea. Kepler has already found more than 1,000 other planets. And it looks like a few percent of all stars have planets where life could exist. Few percent. Maybe 1%, maybe 2%, maybe 10%, but it's on the order of a percent, a few percent. So that means that the number of Earth-like worlds just in the Milky Way is on the order of 500 million, 1,000 million. That number is accurate to a factor of 10. Okay? But that's a lot. That's a lot. And it's hard to believe that they're all sterile. This is another bit of evidence for why we think life might be very common out there. This is a picture I made in Australia. This rock here is a very old rock. We know how old this rock is. It's 3,500 million years old. Now the Earth is only 4,500 million years old. So this rock is almost as old as the Earth. And you see these round things there. Those are the remains of bacterial colonies from 3,500 million years ago. In other words, as soon as the Earth could have life, there was life, very quickly, very quickly. That suggests, it doesn't prove, it's only one sample, but it does suggest that life is not very hard to get started. Right? Nature didn't spend a lot of time on this project. Right? It's like walking into a casino in Las Vegas and putting a coin in and winning the jackpot. That suggests that maybe that wasn't a very difficult bet. So this is another bit of evidence. Now what about intelligent life? What do we mean by intelligence? People often ask me, they say, what do you mean by intelligent life? Is there intelligent life in Washington, for example? Well, what we mean by intelligence is if you can build a radio transmitter so we can hear you, right? So I always suggest to audiences that you ask the person sitting next to you, hey, can you build a radio transmitter? And if they say no, you can avoid them for the rest of campus party. Now, this guy here isn't very intelligent in this picture, but he's adding some RAM to his computer there. This guy, 30,000 years later, was able to build a radio transmitter. And the question is, if I give you 1 million worlds with life and let them sit there for billions of years, how many of them will ever cook up something like you? We don't know the answer to that, and it's very controversial. A lot of evolutionary biologists will say, look, if a rock hadn't, that rock that slammed into the Yucatan 65 million years ago, I don't know how many of you were around for that, but I think that they were really trying to wipe out Campeche. I'm not sure what they were trying to do. But that rock wiped out the dinosaurs and 2/3 of all other species on land. And if that hadn't happened, you wouldn't be here. There would be dinosaurs in Mexico, okay? So it's very controversial whether just because you have a lot of life, you ever get intelligent life. That's not clear. On the other hand, there are some theories about how we got started. And in particular, there's some research that suggests maybe intelligence is not so rare. These data here are due to Lori Marino. She works at Emory University in Atlanta. But what she's done is figured out the IQs, the intelligence of dolphins, right, for the last 60 million years. Okay, so that's 50 million years. That's 50 million years ago. That's today. This is stupid. That's smart. Okay? Now, you'll note that 50 million years ago, the dolphins were pretty stupid. They couldn't hold up their side of the conversation. But then they developed echolocation. They got a little smarter. Then some of them got stupid again. Some of them got smarter. 2 million years ago, the smartest thing on Earth was a dolphin. It wasn't you. It wasn't your ancestors. It was a dolphin. So the point is that dolphins, who are not that closely related to you, right, unless you happen to be a dolphin, that dolphins were getting smarter. Right? They're not related to us. They were getting smarter. As you know, some birds are pretty clever. Octopuses, pulpos, some of them are pretty clever. Right? There are various species that seem to be getting clever, not just us. So that suggests, again, that maybe intelligence will eventually happen on lots of worlds. Okay, so how can we find them? If ET's out there, how can we find them? On television, it's very easy. You just get into a rocket and you go find them. But as you know, that doesn't work, right? Our rockets go like 10 kilometers a second, which is okay if you're going to Oaxaca, although it's not clear to me why you'd want to do that. But if you want to go to the moon, it'll take you a day. If you want to go to Mars, it takes you a few months. But if you want to go to other stars, it takes you 100,000 years for the nearest other star. And that's too long to sit in a coach seat eating peanuts. However, in 1959, these two guys, these are physicists, they were at Cornell University at the time, and they recognized that with radio, you could send bits of information between the stars. We could do that. 100 years after Marconi, we could already do that. In fact, it wasn't even 100 years. Okay. They even told you where you should listen on the radio dial. This is the radio dial, right? Low end of the dial, high end of the dial. These curves just tell you how much natural static, natural noise there is at each part of the dial. There's a lot of noise at the low end of the dial due to what's called synchrotron radiation. Don't worry about it. At the high end of the dial, there are quantum effects in your receiver. They make a lot of noise. But in the middle part of the dial, it's pretty quiet. The universe is pretty quiet. And they suggested you should look between these two frequencies, wavelengths about like that. Okay. We still do that. That's still considered a good strategy. A year after these guys did their work, a fellow by the name of Frank Drake, here's his picture, Frank Drake did an experiment using this antenna in West Virginia. He pointed it at two nearby stars. He listened with the receiver. He was hoping to eavesdrop to hear a radio transmission from ET. He didn't. Well, actually he did, but it was the U.S. Air Force. It wasn't ET. U.S. Air Force didn't count as extraterrestrial intelligence. Okay, but that idea has been continued ever since. This is our own project. From 1995 to 2000, we looked at a lot of stars hoping to find signals using this telescope, which is in Australia, using a telescope in West Virginia, and using the Arecibo telescope, which is in Puerto Rico. Okay? We were looking for signals like this. Signals that are sort of at one spot on the radio dial, right? Because lots of things in space make radio noise. Quasars, pulsars, hot gas, cold gas, Jupiter, the sun, they all make radio noise. But they make radio noise that's all over the dial. No matter where you tune, you hear that static. If you see a signal that's at one spot on the dial, then you say, I don't know what it is, Bob, but whatever it is, it's a transmitter, right? It's somebody built a transmitter, and that's what we're trying to find. This particular signal, by the way, is the Pioneer 10 spacecraft that NASA launched in the 1970s. It's still sending out a signal. It has, by the way, the power of that transmitter is about the same as the power of the light on your bicycle. And yet it's easy to pick up. Okay. This is another way to find ET. Look for flashing lights. Right? Some universities do this. ET could have big lasers, big laser pointers maybe, and aiming them at Earth. And that turns out to work too. I don't know if I'm going to even go through these numbers here. I'm not going to go through these numbers. But we're using this observatory, the Lick Observatory in Mount Hamilton in California, to look for flashing laser lights in the sky. This is an experiment that doesn't require a lot of equipment, a lot of expensive equipment. It doesn't require a big telescope. It's something you could do. You could even do it from Mexico City, actually. You don't even need a dark sky. For about, I don't know, 100,000 pesos, you could buy the equipment to do this. I wish somebody here would do it. Okay, here's the experiment in California. This young student, she was an undergraduate student, actually built the equipment. It was just a student project. All right, here's Frank again. Here's the question I get all the time. You guys have been doing this for a long time now, 50 years. You still haven't found ET. So when is it going to happen? People ask this all the time. They ask Frank this question all the time. And I listened to him in 1990. He said 10 years. And then in 1991, he said 10 years. In 1992, it was still 10 years. Okay? So when is it really going to happen? Right? Well, I'll try and answer the question. I mean, I don't know either, but try and answer the question. First, I'll point out to you, this is just a diagram showing how much of parameter space we've actually investigated in these experiments. And if you get nothing else out of this diagram, you can get out of it that we've barely begun to search. We've hardly begun a search. We've looked at very few star systems. In fact, the number of star systems we looked at is fewer than 1,000. That's nothing, right? This, by the way, is the Arecibo telescope. Anybody been to Arecibo? One guy. You ought to go before they close it. Go see it. It's very nice. It's not far from here either. Go see it. It's 300 meters across. Right? It'll hold 4,000 million scoops of ice cream. Okay, it's Arecibo. But we've been building a different telescope to do this work. This is called the Allen Telescope Array. It's named after Paul Allen, who was the co-founder with Bill Gates of Microsoft Corporation. He gave some money so we could get started with it. That's me. And it consists of a bunch of these small antennas. It's in Northern California. You can go visit it. If you go to San Francisco, rent a car. It takes 5 hours to drive up to it. It's in the mountains. It's very pretty, very nice. Okay, and this, in fact, is the receiving end for each of those antennas. This is the head of the NASA Ames Research Center, by the way. And this thing can receive signals at a very wide range of frequencies on the dial. Okay? This is what it looks like from the air. 42 antennas. 42. That's not many. The idea is to have 350, but there's no money. Okay? The whole problem with this antenna is there's no money. So I don't know how many of you have already earned a few $100 million from your startup companies, but if you have, will you please talk to me after the talk? Okay, but the point of this is that SETI is speeding up. In other words, it's getting faster all the time. Most people think of SETI in terms of what they saw in the movie Contact, right, with Jodie Foster sitting there with a pair of earphones. I have to say, I was an advisor for the movie Contact, and they would call me up all the time asking me, technical details. One thing I pointed out is, actually, we're listening to about 50 million channels simultaneously. So you have to put 25 million pairs of earphones on Jodie, and they didn't do it, but anyhow, the point is that SETI is getting faster, and this little plot shows how much faster it's getting. These black dots show some indication of the speed of these SETI searches since the first one that Frank did in 1960. And you can see the black dots are going up, and they follow Moore's law. And I don't have to tell you what Moore's law is. You can see this is a semi-log plot. In other words, the speed is doubling every 18 months on average. Doubling every 18 months on average. That's why I think you're the generation that will find ET, right? Because the experiment's getting faster. In fact, this plot here, sorry to show so many of these graphs, but what the heck. This just shows how far out into space we could actually search, okay, assuming that we had the money to use to do it. And you can see we go out to 100 light years, 200 light years, and so forth. With time, Carl Sagan figured there were maybe 1 million societies out there broadcasting signals going through your bodies right now. If he's right, then we'll find ET in the next couple of years. Isaac Asimov figured there were like 670,000 societies broadcasting. If he's right, it'll take till 2020. Frank Drake figures there are only 10,000, in which case it'll take till 2025 or 2030. But the bottom line is the same, because all these numbers are the same. The bottom line is this: we will probably find ET within 24 years. And if not, I will buy you a café con leche. All right. So here's the deal for you. Either within 24 years you open up your browser, because there aren't any newspapers anymore, you open up your browser and you read scientists find signal coming from space. Either that or you get a cup of coffee. So that's the deal. Now, assuming we're not missing important physics, that could happen. Let me talk about some things that are a little more speculative. To begin with, one question that you get if you do the kind of work I do is, what would ET be like? Is it going to be a little gray guy with big eyeballs and no hair and no sense of humor? Is that what ET is going to be like? And my colleagues usually respond to this question by saying, it doesn't matter. All that we care about is that ET can build a transmitter, and we don't care what he looks like. But that's wrong. This is a picture from about 1900, so more than 100 years old, of an astronomer by the name of Percival Lowell. Now, he was a pretty famous astronomer in the United States, and he was studying the canals on Mars. Canals on Mars. They had been reported by some Italian astronomers in the 1870s. He could see them through this telescope, and he would spend, you can see in 1900, you would put on a suit and a tie to sit alone all night in a dark dome, right? And that's what Percival's doing here, looking at Mars. In fact, this was one of the many maps he made of Mars, hundreds of canals, right? And in fact, none of these canals was for real, okay? It turns out it was probably an optical illusion. This is a modern NASA photo of Mars here, and you can see these gray areas match up pretty well, but you don't see the canals. This is a picture from a contemporary astronomy textbook from 1900. This is what it was supposed to look like on Mars. I don't know what it looks like. It looks like the floating gardens in Xochimilco, wherever it is, right? That's what it looks like, but there are no people. Okay, well, this was all wrong, but because of the fact that Percival Lowell thought there were Martians who were digging canals, he felt he could find them with a small telescope in Arizona. That's all it took. Okay, here's a picture of this is from 1908. Here you see the Martians at a cocktail party. You can tell the females, right? They wear flowers in their hair and they've got long eyelashes. Okay, but this was all believed by the public. The astronomers did not believe this because they couldn't see the canals. Only Percival Lowell was able to see them. Okay, and it turns out they weren't really there. Finally, in the 1970s, we sent spacecraft that landed on the surface of Mars. Now, most of you are too young to remember this in 1976, 77, when these landers, the Viking landers, plopped down onto the red surface of Mars and opened up their cameras. That was a very exciting moment because nobody knew what they were going to see. Was it going to be little green guys waving back at the cameras? Right? Were there going to be trees? Were there going to be some sort of lichen, moss, something. And all they saw was this, right? Now, you've seen a lot of pictures like this, so you're not surprised, but it was a bit of a surprise. And in fact, one of the scientists at the Jet Propulsion Lab was aware that the public was somewhat disappointed, and he said, well, maybe there's life on Mars that looks like rocks. Could be. Actually, these things that look like rocks turn out to be rocks. Okay, nonetheless, it's still too soon to give up on Mars. Here are some pictures made with an orbiter. This picture was made in 1999. Here's the same crater seen a few years later. And you see that white streak coming down over here. That's probably due to water coming out of the side of the crater. Because what you really want to do if you want to find life on Mars today is you send Bruce Willis to Mars with a bunch of roughnecks, have them drill a hole 1 kilometer deep and pull up the wet muck, because it's probably wet down there, and look at it under a microscope, and that's the way to find the Martians. So you see, it really does matter what your vision of the aliens is like, because if you think that they're guys like us that want to dig canals, then you can find them in Arizona with a small telescope. But if you think, as we do today, that Martians might be little microscopic things deep under the ground, now you have to send some sort of robotic drilling apparatus to Mars. So it's important to think, what is it that you are looking for? And that's what I will finish this talk telling you about, just give you some ideas. So how we picture ET matters. All right, this is the way we usually think of him in terms of science fiction, but even in terms of science. Carbon-based life forms. You're carbon-based, right? There's a lot of carbon in your body. Why? Is it because there's more carbon out there than anything else? No. It's just that carbon is a friendly atom. It likes to hook up with other atoms to make very complex molecules. Here's the periodic table. You probably haven't seen this for a few years, unless you're a chemistry major. But there's the column with carbon up there. Carbon. Carbon. Okay. Carbon has these 4 covalent bonds. It loves to hook up with other atoms. But right underneath is silicon. And there's more silicon out here than there is carbon. So maybe ET is silicon-based. I don't know, it doesn't work as well as carbon because silicon's a slightly bigger atom. So it doesn't really make such interesting compounds. How about germanium? Maybe germanium-based life. Tin-based life? In The Wizard of Oz, they have tin-based life. Lead-based life. I don't know. But carbon is not an accident, is what I'm trying to tell you. So we assume that ET is probably carbon-based life. Okay? Other things, Homo corrali cares about that. On a planet with plate tectonics. It's good to have plate tectonics, even though it causes earthquakes here. The plate tectonics mean, in fact, that you bring some of the precious metals up to the surface, right? The silver and gold that so interested Cortez, right? That's due to plate tectonics. And without plate tectonics, you also wouldn't recycle the carbon dioxide in the atmosphere. It would get very cold on this planet. So you assume that ET's on a planet with plate tectonics, bigger than a rat, smaller than 10 elephants. That's because if they're really tiny, they're probably not very smart. You can't get a lot of brain cells in there. And if they're bigger than 10 elephants, they have a hard time walking around. Right? So these are probably, this is true, they have to be able to pick up a pair of pliers or a screwdriver if they're going to build a transmitter. Stereo vision, helpful to have stereo vision. If you have vision like a cow or a fish, it's hard to put things together. I mean, these people over here who are building the intergalactic fleet all had stereo vision, right? Okay. So the bottom line is we assume that they're somewhat like we are. This is what we've always assumed. But I suggest to you that this is wrong. Okay, here's why. I show this plot in every talk I give because I really like it. This is a plot that was made by Hans Moravec. He's a roboticist, builds robots at Carnegie Mellon University in Pittsburgh. But, this is based really a lot on the ideas of Ray Kurzweil, who's going to be at Campus Party later in the week, I believe. Ray Kurzweil. Anyhow, all it shows is how much computer power can you buy for $1,000 since 1900. And you see it goes up, right? Okay, now, this graph runs out in 1997. 1997 for $1,000, you buy the computing power of a spider. I don't know if it interests you. If you're an arachnophile, maybe it interests you. Today, 2011, for $1,000, you buy the computing power of a lizard. Okay? Still not very interesting. But the point is, by 2020, for $1,000, by 2020, your laptop, your desktop, all the machines sitting on these tables will have the same compute power as you. Okay? Now, that doesn't mean they're going to be able to think, because that's a much harder problem than building the hardware. But will we ever be able to make a machine that can think? And you'll get different opinions depending on whom you ask. But my opinion is yes, right? I mean, if I ask you, could we build an artificial heart? You'd say, oh yeah, we can do that. I say, could you build an artificial kidney? Oh, yeah, sure, we can build it. But I say, well, what about that organ between your ears? Could we build an artificial brain? Some people will say, no, that's sacred, man. Can't do it, right? They're wrong. I think they're wrong. When will it happen? Well, it might not happen in 2020. It may not happen in 2030. It may not happen in 2050. But it may happen by 2100. It may happen in your lifetime. It may take another 2 generations. Doesn't matter. The point is that once you do that, then the artificial intelligence improves much faster than biology. This little cartoon gives the idea. Here's the history of a horse. 50 million years ago, 60 million years ago. 60 million years ago, a horse was the size of a dog. Today, a horse is the size of a horse, right? Now over here we have computers. I had a computer in 1977, home computer. And the one I have today is, I reckon, 10,000 times faster than the one I had in 1977. So once you have artificial intelligence, it gets better very, very quickly. You don't get better. I mean, you get a little better. Maybe in 10,000 years you'll be a little better, right? But the machines will be a lot better. So they completely overtake you. Now you might say, oh, well, yeah. So you have artificial intelligence, so what? Well, artificial intelligence has a lot of advantages, right? I mean, obviously it's smarter, but it might not die very soon, right? You get an education, you go out and work for 40 years, then you retire, and then they put you in the ground, along with a hard drive and everything else, right? That's crazy, right? But the machines don't have that problem. To the extent that they're immortal, they could make long trips. They could go to the center of the galaxy or something, right? If you don't die, you don't mind that the trip takes millions of years, okay? So there are a lot of advantages to machine intelligence. So my bottom line here is that while the movies and television have convinced you that what we're looking for is some sort of soft, squishy, protoplasmic, big-eyed alien, like this one, that you can forget all that, because that's not what it's going to be. It's going to be some sort of machine, most likely. Because the time scale to go from the invention of radio to the invention of our successors is only maybe a couple of 100 years. That's short. Okay, so what would they be like? What would these artificial intelligences be like? Ray Kurzweil says that they will be nanobots. Nanobots. And in fact, Ray figures that the nanobots will spread out through the cosmos, maybe eating everything in sight, right? Well, maybe. That doesn't, to me, that doesn't seem so reasonable, because if you spread them out, then they can't think very fast. It takes too long from a thought to get from that part over to this part. So, you know, I'm not so sure that that'll happen. And if they're really eating everything in the universe, well, that's bad news, because they've just turned the whole universe into a garbage dump. Maybe the best thing to do is to have all the thinking parts concentrated so that the thoughts can be faster, the time of flight is faster. Maybe they're big hunks of thinking machines floating in space or sitting on planets. We don't know. But they don't need a planet like Earth. That we do know. And so when we point our antennas into space, just looking at planets that are like our own is maybe too short-sighted, too myopic, not thinking out of the box enough. Because, as I say, my argument is the majority of the intelligence in the cosmos is not biological. So, finally, where should we look? I don't know. I don't know where the machines might be, but this is one place where they might go. This is an infrared photograph of our galaxy, and you can see the bright spot in the center, which is the center of the galaxy. It's 26,000 light years away, but there's 1 million times as much stuff per cubic meter there as here in Mexico City, and in fact, there's also a lot more energy. There's a big black hole there that you can use to get energy. So that's one place we ought to look. We almost never look in this direction. We ought to always have some antennas, some telescopes aimed in this direction to see if any very advanced machinery has ever gone to the center of the galaxy, knowing that anybody else will always look in that direction. Okay, as for our descendants, I don't know what's going to happen to us. I don't know whether we'll still be running this planet 500 years from now. All I can say is that it's very possible that our great-great-great-great-great-great-grandchildren will also go to the center of the galaxy. Okay, I'm going to stop there and allow you to ask questions. I'm sorry for the tedium of the English. Thank you.
Bueno, estoy segura que hay muchísimas preguntas. ¿Quién quiere empezar? Ahí, Mario, por favor.
If you want to ask in Spanish, you can. Somebody will translate, I'm sure.
I have a very short question. The graph you showed on the year we're going to make first contact, depending on the number of civilizations, is based on what computing power and what listening radio telescopes, and if the stalling of the Allen array will impact on this anyhow.
Okay. Mario refers to something that you may have read, that the Allen telescope array is not operating now because there's not enough money. Okay? And we're trying to raise that money, and I hope we will find it. On the other hand, let me point out that we are not the only SETI experiment. There are several SETI experiments in the United States. University of California at Berkeley, obviously the SETI Institute, and also Harvard University are all doing SETI experiments. The rest of the world is doing very little, very little. The only other country that is routinely doing SETI is Italy, the University of Bologna. And I think that there's something very interesting about this, because I don't know why other countries are not doing this. The European countries, many Asian countries, certainly many South American countries, have the equipment, you have the expertise, you have the money, I think, right? And yet they don't do it. There's something cultural in that, something cultural. If any of you are studying anthropology, I wish you would look into this. Tell me what's the answer. Why is it only the crazy Americans do this?
Siguiente pregunta.
Hi. You said earlier that if we thought about a species or a race or something like that as a carbon-based life, that we had to thought about probably a plutonium-based life or arsenic-based life. But my question is, if we thought about that, what about the radio signals that we receive? Do we think, or are you thinking, excuse me, that we only have to receive radio signals as we perceive it, as we think about it? Is there any other kind of signals that we have to process of other worlds? Do you understand what I'm saying?
I think I understand. You're wondering whether we're not being too narrow in looking only for radio signals or light signals, flashing lights. Could there be some other way to communicate? Well, maybe there is. I'm open to suggestions. I get about 5 emails every week, by the way, from people who have suggestions. They say things like gravity waves. I don't see any advantage in gravity waves. They don't go faster, and they're very hard to make. Neutrinos, things like that. Neutrinos are very hard to do, too. With the physics that we know, there doesn't seem to be any better way to communicate in terms of the energy cost and the speed. Radio waves, light waves, they're really the same thing. Seem to be the best way to do it. It could be that there's some physics we don't know that would allow it to be otherwise, but we haven't heard about that. You could ask Michio Kaku, he'll be here.
Siguiente pregunta, allí atrás.
This is not a question very scientific, and I mean you're a researcher and stuff, but I'm wondering what's your point of view on the Area 51 stuff, Roswell, all that stuff that went on in New Mexico and that goes on in the movies and stuff like that. What do you think about that from a scientific point of view?
Right. Well, the gentleman is asking about what we call UFOs in English, and you call OVNI, right? Could we be being visited right now by aliens? Now, in the United States, I don't know what it's like in Mexico, but in the United States, 1/3 of the population thinks that the aliens are here, buzzing the countryside and occasionally taking you out of your bedroom for experiments your mom would not approve of, right? 1/3. Now that's the same in Canada, that's the same in Britain, it's the same in Australia. I think it's the same in South America, I don't know. I think I saw a survey. I don't know in Mexico, but it's probably the same in Mexico, right? Now, is there any good evidence for that? I don't think that there is. If there were good evidence, you would have people at the university here studying that. And they generally don't. It would be the most interesting story in the world. So why is the evidence so poor? Why can't I go to the Science Museum and see the evidence? Right? What about Area 51? Well, it's an Air Force secret area, but they test airplanes there. I don't have anything to do with aliens. Right? Okay? So what people say in the United States who think we are being visited, they say, look, the U.S. government is keeping this a big secret. And the reason they're keeping it a secret, because I always ask, why? Why wouldn't you just have thousands of university academics, working on it? And they say, we have to keep it a secret because otherwise the public would go nuts. They would panic and they would riot in the streets. Right? Look, 1/3 of the public thinks it's already true that they're here, and they're not rioting in the streets about it. Right? Go down to Zocalo and you will not find people rioting in the streets about aliens being here. And you can think that the U.S. government is covering this up, but you also have to assume that the Bulgarians and the Botswanans and the Hondurans and the Guatemalans and the Mexicans and that they're all keeping it quiet, unless you think that the aliens only want to visit the United States. Doesn't make sense.
Hello, my name is Gabby. I am a graphic designer, but I love all of this about the universe. Maybe my question is out of the place, but I have always been wondering, we always supposing that life comes out of carbon and all the things that we know because we see it, because we have the proof. But what about life that maybe it doesn't, maybe it's just out of these components, or maybe, is it possible? Because I'm always defending this about life in the universe with everyone, No, I think that there is always a possibility, So I want to know your opinion of maybe I'm just been watching too much TV.
Well, watching any television is watching too much. Look, I have to say that I do get a lot of emails from people who suggest, you people are too conservative, always looking for carbon-based life form. I just told you not to look for carbon-based life form, but anyhow, right? But, couldn't there be life based on something we don't know about? Well, of course. I mean, we don't know what we don't know. Right? But having said that, then you're stopped. Then you're stuck. You can't go any farther. You can say, okay, you think it might be based on something we don't know about. So how do we look for it? What does it look like? How do we find it? And you can't answer any of those questions unless you know something. That's the problem. It's like saying the aliens aren't going to use radio waves. They're going to use zeta waves. But nobody knows what a zeta wave is. How do you build a zeta wave receiver? That's the problem.
Another question there?
Okay, first of all, thank you for the conference, the talking. Now, I know that, the stars are not the same. There are blue stars and red stars. So I would not search a planet in a red giant, because there are like Cepheids. So there are another characteristics in the stars to find planets around them, like, I don't know, metallicity, color. Okay.
Okay, I think your question was, aren't there certain kinds of stars that would never have intelligent life around them, right? Like red giants, blue giants, those sorts of things. That's true, but you don't have to worry too much about that, because the giant stars, which don't live very long, so they're probably not going to cook up anything interesting. That's only 1% of all stars. See, 90% of all stars are red dwarfs. Sounds like a British television series. Red dwarfs. Okay, 90%. And we know red dwarfs can have planets. And we also know that red dwarfs live for a long time. It takes a long time for a red dwarf to burn out, like 100 billion years. Right? So plenty of time for them to cook up something interesting. And most of the rest of the stars are sort of like the sun. So yes, there are a few that you can throw out, but it's very few. It's a percent. It doesn't affect things very much. But you know some astronomy, and that's always good.
Otra pregunta ahí.
Thank you very much. Do you think, as a scientist, that those signals in the crops are over here?
Oh,
Okay. That, for example, those signals in the crops, the famous ones in England, are man-made or could be, I don't know, maybe intelligent form in any other planet? You
the
think
gentleman
it's real?
refers to what are called crop circles. Did anybody see the movie Signs? With you? Okay, crop circle. Look, I got to ask you. Do you think it's reasonable that a very advanced society? I mean, just imagine, you're in the Senate of a very advanced society, right? 100 light years away. Okay. All right, Senator Zork. What you're proposing is that we spend 100 trillion galactic cruceros to build these giant spacecraft and go 100 light years to that blue planet over there, and then go find England when we get there, and then carve graffiti in their wheat, right? Would you vote for that? I don't think they'd vote for that. But even if you think they'd vote for that, these crop circles appear overnight and usually on a weekend, right? I think that suggests that they might be due to students, not to aliens. It doesn't make any sense to come this distance to try and communicate and make patterns, because they're mostly patterns. There's very little information in these things. Even theoretically, there's no information in them. And then the next day, the farmer mows them away anyhow. And why do they only want to talk to the British? Right? Why? I mean, nothing against the Brits, but I mean, why? So now, the other thing that people say, well, what about the Nazca lines in Peru, right? I mean, those Indians could never have made those complicated patterns in the dirt. What? I mean, that's crazy. That's like saying, look, the pyramids here in Teotihuacan, the Aztecs couldn't have built those things. They would have needed alien help. You know, nobody says that about the Colosseum in Rome. These Romans could never have built this thing. They must have had alien help. Nobody says that. It is some sort of, it's a kind of a cultural racism in a way, that the Peruvians couldn't have built these lines. Of course they could. In fact, there's good evidence they did. So I don't think the aliens would come here and, you know, make these patterns. Doesn't make sense. I think if they were here, you'd know, actually. I mean, let me just say one more thing. If you would ask the average Aztec in 1540 or something, said, hey, do you think you're being invaded by Spaniards? Do you think they would have said, well, I don't know, maybe, but maybe not. I mean, I'm not sure. They wouldn't have said that. They knew. They really knew. I think you'd know. Okay, have you had enough? Or is...
Allá hasta atrás hay una. Córrele.
Have I insulted you enough?
Hi. What about life based on antimatter? We know not too much, but and the universe is mostly matter and antimatter, I think. But what about if life could life be based on antimatter and communicate with us by sending radio waves and those things?
Yeah, you could have life based on antimatter. There'd be anti-aliens or something. I don't know. You could, in theory, because the chemistry would all work, right? So you could have life based on antimatter. The problem is that there isn't very much antimatter nearby us, right? It's very hard to find antimatter, and we've never found an antimatter star or an antimatter planet. Now, it may be that this particular part of the universe has a lot of matter and very little antimatter, and if you could only go, 20 billion light years in that direction, you might find a part of the universe that's mostly antimatter, and maybe there's some antimatter intelligent beings. But they're so far away, you have very little hope, no hope really, of ever hearing anything.
Bueno, chicos, tengo una sola última pregunta que va a estar allá.
The last one.
Después vamos a tener una sorpresa para ustedes.
Thank you very much. Good afternoon. My question is that you said that the future of our research for extraterrestrial intelligence is on the center of the galaxy, right?
Well, that's one place I would look. I gave that as an example.
The problem is that in the center of the galaxy there's a lot of noise. And there's a lot of galaxy, a lot of energy, and do you think that it really worth look in there? Well, we have programs with the echoes of the Big Bang. So do you think that that we can develop features that let us reach intelligence there? And if you think that we can develop them, in which time, in which future?
The answer to your question is yes, I think we can. It's true that, for example, the echoes of the Big Bang, that's radio noise that you find essentially everywhere. It's strongest in the millimeter wave region, but it's everywhere. But it's very broadband. It's broadband. And the galactic center makes a lot of radio noise too, but it's everywhere on the dial. Whereas transmitters can put all their power in a narrow part of the dial, right? Now think about it. If you're driving around the city in a lightning storm and you see a lightning flash, you'll hear it on your radio too, right? And it doesn't matter where you're tuned, you'll hear crack, right? Because it makes radio waves along with the light, and they're everywhere on the dial, whereas your favorite radio station's at one spot on the dial. So the big advantage that a transmitter has over these natural radio emitters is that it puts all the energy into a narrow band. And that you could hear from the galactic center if they wanted to do it. You could do it. It's not impossible. Okay, well,
bueno, desafortunadamente.
Thank you very much. I'll be around. If you have other questions, you can come ask me. Thank you.
Seth, would you like to do the honors? Would you like to introduce Tom?
Bueno, le voy a dar la palabra a nuestro flamante coordinador de área, John Alexander Dolan.
Bueno, les tenemos una sorpresa. Seth les va a introducir a un amigo.
Oh, well, I don't want to. But the next speaker is Don James from NASA Ames Research Center. And I encourage you to listen to Don. Don is here. I think it'll take 3 minutes to change the technology. I'm not sure.
Let's see. I have to look at my notes on my iPad. I think I can do it. I work for NASA. We can do a lot of things. All right. What? Do I have to sit? Oh, I want to stand up. Okay. Thank you for staying around for the epilogue. You know, when Dr. Shostak was talking about the people who think that they're aliens that are actually walking around on Earth?
Job security for me.
I work for the government. I'll tell you where all the secrets are. I know where all the little green men are. So let me just pull up my slideshow. I work at NASA Ames Research Center in California. How many of you know that there are 10 NASA centers in the United States? 3 of them are in California. You all know that, right? Well, now you do. So you're going to pass the quiz at the end. Ames Research Center actually began before NASA was created. Everybody knows when NASA was created, right? When was it created? Okay, here's math. Everybody's smart in math. So NASA was created 1 year after I was born, and I am 54 years old. So when was NASA created? 1958, yes. I heard somebody say that. So the purpose of NASA when it was created is to expand human knowledge and to cooperate with other nations and to share information. That was one of the purposes NASA was created. So a lot of what we do is to share the information that we do. And so what I would like to just share with you briefly, I only have a handful of charts. I'm looking at my notes. I just was asked to do this yesterday, so I wasn't very prepared, but I hope this is useful to you. So NASA has 7 strategic goals. I want to just talk about 2 of them because it's important for what I'm going to say later. One of our strategic goals is to extend and sustain human activities across the solar system. That's what NASA is about. The second thing that I want to tell you is that our goal is to share NASA with the public. So you are the public, and I am NASA. So I am sharing with you. So I am doing my job. Please tell that to the people who say, why are you in Mexico having fun at the campus party? We share NASA with the public and with educators and students. and provide opportunities to participate in our mission, to foster innovation, which I see a lot happening here, and to contribute to a strong national economy. So, how many of you know that we have a space shuttle up in orbit right now? Yes? The very last one, Space Shuttle Atlantis. And as a reward for your sitting listening to me, I brought a photograph of the astronauts that are on the shuttle that are in that bag right there. But you have to stay until I finish, and then I'll give you the photo after that, okay? I'm not in the photo because if I was in the photo, I would actually be up in the space shuttle and I wouldn't be here talking to you. So the message that I want to share with you is the space shuttle program is coming to an end. No more space shuttles built by the United States government. But NASA continues to work on space exploration. We are supporting commercial industry to build rockets to take our astronauts to the space station. We are working on a new crew vehicle to take astronauts. It's called Orion. I had the privilege when I spent some time at Johnson Space Center to work on the Orion capsule. We are soon going to talk about the new launch vehicle that we're going to use. So just because there's no more shuttle does not mean that we're stopping, that NASA is not stopping space exploration. We are still going to send humans into space. One of our goals ultimately is to send humans to planet Mars. As you know, as very, very bright people, it's easier said than done. It takes a long time to get there. We have to worry about zero gravity on our bodies and our physiology. We have to worry about the technology and the cosmic rays. We have to worry about, well, there's no Starbucks on Mars, and that rules me out right there. But that's the goal. In addition to that, we hope to be able to visit asteroids with humans, perhaps go back to the moon. But that's what NASA is about. We need to develop the technologies to do that. So a lot of what our investments in NASA today are the technologies to do that because we don't know how to do some of these things. The International Space Station. We have completed building this wonderful laboratory. I really hope that some of you will propose science projects to fly on the space station. Maybe it's an engineering project or a science project or something. The goal is to keep it there till 2020. I think it should be up there for longer. We spent a lot of money on that, the United States and other countries. But now we have 6 astronauts 24/7 on the space station to do science. NASA continues to do work in aeronautics. Of course, you all know that NASA is an acronym, and the first A in NASA stands for aeronautics. Our goal in aeronautics is to make sure that if you flew to Mexico to come here, that you got here safely, that when you fly back to wherever you go, that it'll be safe. We want to make sure that airplanes don't run into each other. We want to make sure that they are more fuel efficient, what we call green aviation. We are doing research at Ames on that, looking at biofuels for jet engines. We want to make sure that they use a lot less fuel, because that's one of the highest part of the cost of aviation. So NASA continues to do this. In science, you know the Dawn spacecraft has just arrived at the asteroid Vesta and bringing back pictures. You probably saw it online. Dr. Shostak talked about the Kepler mission, which is finding planets. Now, I have to tell you, I really find that cool because when I was little, the idea that there are other planets, perhaps like Earth, that didn't exist. And now we know that they do. And so I certainly hope in my lifetime, and Seth, I hope you speed up the bit about when we're going to connect with ET. I would love to know that we've confirmed that there's some kind of intelligent life. I believe it does. I personally think that it's arrogant for us to believe that of the billions and trillions of star systems that could accommodate planets that we're the only one like that. Maybe it's true. I don't know. I'm not out there, but I believe it's true. We have an aircraft called SOFIA, Strategic Observatory for Infrared Astronomy. It flies above all of the smog and the water so that we get a nice view of the stars in the infrared spectrum. And our scientists at Ames are now conducting studies with instruments coming from all over the world. It's a great aircraft. Perhaps you can propose an instrument to fly on SOFIA. And finally, I want to tell you, which is near and dear to my heart, NASA has always been committed to education. For those of you who are aware, particularly in the United States, that we have a problem with young people being interested in science and technology and engineering and math. In fact, the reason that I'm here with my colleague Steve and Bill from NASA Ames is that we're trying to decide if we can have a campus party for the first time in the United States in Silicon Valley. I think it would be cool if we could pull it off, but we have to figure out if we can pull it off. But education is really important. And what we want to do is use the things that are unique to NASA, that no other organization does, to get people excited about the future. When Space Shuttle Atlantis launched from Kennedy Space Center, there were 500,000 people watching that. Now, why is that? We've launched 130 space shuttles, and yet this was the final one, and yet people wanted to see that. I've been to shuttle missions, landings, where we've had almost 1 million people just to watch the shuttle land. I think there's something about our desire to know and to explore and to search that is a part of all of us in whatever area that we're interested in. And it's important for us to use what we do at NASA to inspire our young people to get an education. And finally, the last thing that I would like to share with you, and I would like to acknowledge Mad Dog Hall for this suggestion, because I asked him, what should I share with these people? One of the things that I've been very interested in is, what is it that students ought to learn? I get questions all the time. Mr. James, what can I study in order to be an astronaut? And, should I do more math or biology, or what do you think? I never give them an answer. Of course, the right answer is you need to follow your heart and your passion and explore what makes your heart sing and what you want to contribute. But I think that there's some core things that not only every student ought to know and be able to do, but all of us. As a matter of fact, when I talk about students, I'm talking about you and me. School is forever. If you thought school was over, school is forever. You're always in school. When you're in campus party, you're at a campus. Campus means school, so that you're going to learn. So here are the things that I found about a group of people who felt that for the 21st century, these are the skills that all of us, particularly students, need to know how to do. You will recognize a lot of these. First, you have to be a critical thinker. What does being a critical thinker mean? It means that if 1/3 of the public in the United States thinks that they're aliens that are in the country right now, that a critical thinker might say, well, I'm not sure. How would we know if that's true? And they would dig a little deeper to find out. That's my view of critical thinking. The second thing is you need to be a problem solver. You all remember Apollo 13? And the tank blew up, and they had to get all the junk that they had out there and say, figure out how to make an air filter, because if you don't, they're going to die. I'm telling you, if I was up on Apollo 13, I'd want a whole lot of problem solvers in Houston solving that problem, because my life depends on it, okay? Secondly, to be an innovator. I mean, look at this place. There's going to be businesses coming out of this place. There's going to be new innovations that are going to come out of this place. There's going to be things that are going to probably change my life or my children's life. And being an innovator, for me, means that you're willing to take a risk, you're willing to make a mistake, you're willing to fail, you're willing to be wrong, you're willing to be ignorant, but you're open to the possibility that others could help teach you something that you didn't know, that you didn't know you didn't know. An effective communicator. If I do a good job as an effective communicator, you will remember at least one or two things that I tell you. Well, here's the answer to the quiz. This is all I want you to remember, that The end of the space shuttle program does not mean the end of the human spaceflight program for NASA. You got that? We are continuing to do it. That's the answer to the quiz. A self-directed learner. No longer is the world of education, in my view, going to be about sitting in a classroom and there's somebody that knows something and is going to tell you something and you're going to say, I got it, I know something now. You have to go out and you have to learn yourself and you have to collaborate with your other caseros and find out what it is that you need to know. Self-directed learner. Information and media literate. I think that's a given. Globally aware. This is something that I tell a lot of students in the United States about, being globally aware. I can tell you there are a lot of people in our country, including myself, who 5 months ago had no idea that something like this existed. I was not aware. And I am blown away by what I'm seeing. Critically engaged, okay? You're not just a passive recipient of the data that you get. You're engaged, like the questions that people were asking earlier. And finally, to be financially and economically literate. I think that if we had more people that were financially and economically literate, we would not be wondering whether or not the United States is going to default pretty soon. And I sure hope it doesn't, because that means I probably won't get a paycheck, and that means I can't buy my Starbucks latte, and I'll be very sad. So, I'm just kidding. So, those are the 21st century skills that a group of experts conclude that we need to be about. You know, it's not about being better at calculus or knowing your physics. That may be important too. But if you work on this, then I believe and they believe that our world will be better, because I believe that we have a common goal. And our common goal is to advance the human condition, whatever that looks like. So I thank you for staying around. As a reward, you get to have a picture of the astronauts. And do you want me to answer questions too?
If you want.
Okay.
Can you?
I'm at your mercy. Thank you for listening.
Thank you very much for this inspiring talk. 3 questions. No questions. Well, yes.
Okay, thank you for the information. My question is there any scholarship program for NASA? I don't know. I'm going to do my master's and then my PhD, and I will very please. I know.
You want to come work for NASA?
For my PhD.
It's possible.
It's possible?
We actually have internship possibilities for people who even are not citizens of the United States. It's rare, but it's possible. So see me and I'll let you know how you can do it. Yes. Yes, sir.
Thank you. I just want to know if Virgin Atlantic is working right now with NASA in the project of the new spacecraft. I don't know.
Yeah, you know, I think of all of the commercial companies trying to go into space suborbitally, I don't know the degree to which NASA has a role in that. I do know that we have worked with SpaceX. In fact, at NASA Ames Research Center, one of our capabilities is the reentry materials, thermal protection systems. You know, we like to say that if you want to go into space, you go talk to our friends at Marshall Space Flight Center in Huntsville, Alabama. But if you want to come back, you have to come to Ames, because we'll keep you from burning up. So we did that support with that group. With Virgin Galactic, I'm not sure. What I will say is NASA as an agency is supporting the development of commercial companies to be able to access low Earth orbit. NASA wants to get out of the business of sending spacecraft and astronauts just to low Earth orbit that NASA builds. We want the commercial companies to do that. We believe they are ready. In fact, we believe and want them to take our astronauts to the International Space Station. But I don't know specifically about Virgin Galactic. I wish them well. Maybe if I was younger, I would try to save my money and buy a seat for 6 minutes of floating. But I think it's a wonderful thing, and I think it's like the beginning of aviation, you know? The development of investment in aviation in the early years led to commercial aviation. I see it the same thing with space travel. Yes?
I'm not worried about the future of human flight. I'm quite sure it will continue with or without NASA.
Mm-hmm.
But there were several articles last week in magazines' opinions that were worried about the future of the James Webb Telescope.
Yes.
What's the status of that, and what's the position of NASA?
Let's see, they're streaming this live, which means a lot of people are watching this, which means my answer could be career limiting. So I'm not an expert in James Webb. What I know is what I read. I have not read anything official from the agency. I do know that actually that question is probably better addressed to Seth, because I know he just wrote something about that, and he has things that he could probably share. So Seth, you want to take that on?
No.
Thank you. I'm trying to be honest. I'm not trying to be cute. I'm trying to honor being critically engaged and be a critical thinker. I have not done my homework from the NASA side about James Webb. I am aware of the cost overruns. I'm aware that there's concerns about the viability of it. I'm also aware that of the scientific possibility of James Webb makes Hubble look like a pair of binoculars. But let me leave it at that, because I don't want to misspeak, because if I misspeak, then I may not get to speak again.
I will just say, this is not a done deal. The James Webb Telescope has not been canceled yet. It's one branch of the legislature has recommended that. The problem is it was originally budgeted at $1 billion, and the price tag keeps going up. And the danger is not that NASA doesn't want to build James Webb, and not that the scientific community doesn't want to have the telescope. It's that if you don't increase the total NASA budget, then you can only continue to work on the James Webb Telescope if you sacrifice a lot of other research. And that's a real catch-22 situation that nobody wants to be in. But there's this. James Webb is the successor to Hubble, not because it's a better Hubble. It's because it looks in the infrared, which means it can look back to that time when the universe was dark. When it was dark, when there were no stars. It was completely dark. And it was dark for maybe a few 100 million years. And that's when galaxies began to form. You want to understand how the universe came into being, you have to build James Webb. So it's a political issue, it's an issue of money.
Thank you. Bueno, me gustaría que todos agradeciéramos otra vez a los dos speakers por sus estupendas pláticas.
Thank you.
Thank you. Para hacer esto de las fotografías un poquito más organizados, vamos a intentar hacer una fila, ¿ok? Gracias.
I think she's going to hand them out.
Hand them out.
It would be better, yes.